What is occupational disease? An occupational disease is a health condition or disorder, e.g., cancer, musculoskeletal disorders, post-traumatic stress, etc., that is caused by your work environment or activities related to your work. In general, health conditions or disorders that occur among a group of people with similar occupational exposures at a higher frequency than the rest of the population are considered to be occupational diseases. How occupational disease are identified? Determining if an exposure at the workplace, the cause, results in occupational disease, the effect, is a complex issue. Many criteria must be considered. One set of criteria that is commonly used is credited to Dr. Bradford Hill from 1965. While Bradford Hill did not intend this list to be used as a checklist, it often is. Rather, he intended these considerations as a starting point, saying that, none of my 9 viewpoints can bring indisputable evidence for or against the cause-effect hypothesis, and none can be required as an essential element or condition. What they can do, with greater or less strength, is to help us to make up our minds on the fundamental question: is there any other way of explaining the set of facts before us? Is there any other answer equally, or more, likely than cause and effect? Strength of association. The stronger the association, the more likely that the relationship is causal. Heavy smoking is associated with 20 times the increased risk of lung cancer and only 2 times the increased risk of coronary heart disease. The association between smoking and lung cancer is far more likely to be causal than the association to heart disease. Consistency. The association is consistent when the results are confirmed by different people, in different places, circumstances and times, using different experimental methods. This consideration is why many different studies need to be done before meaningful statements can be made about the causal relationship between 2 or more factors. For example, it required thousands of highly technical studies of the relationship between cigarette smoking and cancer before a definitive conclusion could be made that cigarette smoking increases the risk of lung cancer. Tools like a meta-analysis means that studies that meet certain inclusion criteria are gathered and analyzed together. The conclusions from meta-analyses are much stronger than those from a single or a few studies. Specificity of association. Specificity of association means that there is a one-to-one relationship between the cause and effect, or one cause equals one effect. An example of specificity of association is mesothelioma, a form of cancer that is believed to be only caused by asbestos exposure. It is a one-to-one relationship. Specificity of association is considered by some to be the weakest criteria of causation. For example, it does not hold true for cigarette smoking and lung cancer. If you smoke, you do not have a 100% chance of developing lung cancer. Likewise, if you have lung cancer, it does not mean that it is 100% certain that you were exposed to cigarette smoke. Temporal relationship. The exposure must always precede, come before, the outcome or effect. This consideration is essential. If smoking is a cause of lung cancer, the smoking must occur before the cancer, not after. Biological gradient, dose-response relationship. Biological gradient refers to exposure levels and resulting health effects. An increase in the exposure increases the effect or disease incidence. A lower exposure decreases the effect. The presence of a dose-response relationship is strong evidence for a causal relationship. If you consider our smoking and cancer example, light smokers would be less likely to develop lung cancer than moderate smokers, and both of these would be less than heavy smokers. This effect is known as a dose-response relationship. However, a threshold may exist below which the effect of interest will not be seen. Stated another way, the exposure may be so low that the effect is not observed or is very rarely observed. This observation does not mean that the exposure does not cause the effect. In addition, sometimes a low exposure may produce no effect, a moderate exposure may produce a beneficial effect, e.g., a drug or vitamin, and a high exposure may cause harm. Plausibility. Plausibility asks, does the observed relationship make sense considering current scientific knowledge of the pathological processes? For example, one may, by chance, discover an association between the price of Tim Hortons donuts and election results in China, but there is not likely to be any logical connection between the two phenomena. Also, consider the concept of latency. Was the timing of exposure and disease development biologically plausible? Coherence. Coherence means that the association should not conflict with existing theory and knowledge. In other words, it is necessary to evaluate claims of causality within the context of the current state of knowledge within a given field and in related fields. However, remember that research that disagrees with established theory is not necessarily false. It may, in fact, force a reconsideration of accepted beliefs and principles. The difference in Bradford Hill's definitions of plausibility and coherence is subtle. Plausibility is worded positively. An association should be in line with substantive knowledge. Coherence is verbalized negatively. The association should not conflict with substantive knowledge. Plausibility asks, could you imagine a mechanism that, if it had truly operated, would have produced results such as those observed? By contrast, coherence asks, if you assume that the established theory is correct, would the observed results fit into that theory? Experimental evidence. Does experimental evidence support the cause-effect relationship? Can researchers design an experimental study to confirm the observed relationship? In a workplace setting, if the dust in the workshop is reduced or lubricating oils are changed, do you get different results? Is the frequency of associated events, asthma or skin rashes, reduced? Analogy. With analogy, knowing that a drug like thalidomide or a virus like rubella can cause birth defects makes us more willing to accept similar evidence when attributing these effects to a closely related drug or virus. Current science relies on this type of consideration with information from computer-generated structure-activity relationships for chemicals. This type of information helps identify the potential for harm so that expensive human population and animal studies can be more targeted or avoided completely. Adapted from A. Bradford Hill. The Environment and Disease, Association or Causation. Proceedings of the Royal Society of Medicine. 58, 1965, 295-300. As noted above, making associations of cause and effect must be done with caution. Other authors caution that Section statistical significance should not be mistaken for evidence of a substantial association. Section association does not prove causation. Other evidence must be considered. Section precision should not be mistaken for validity. Non-random errors exist. Section evidence, or belief, that there is a causal relationship is not sufficient to suggest action should be taken. Section uncertainty about whether there is a causal relationship, or even an association, is not sufficient to suggest action should not be taken. 2. Statistics on occupational diseases. In total, 4.619 reports of occupational diseases were registered at the Netherlands Centre for Occupational Diseases, NCVB, by 792 Dutch occupational physicians in 2017. This emerges from the Statistics on Occupational Diseases 2017. Mental diseases accounted for 57%, 2.639 reports, and related primarily to stress-related disorders and burnout. Another large number of reports were related to musculoskeletal disorders, 1312, 28%, like soft tissue disorders of the shoulder and upper arm, 223, 17%, epicondylitis lateralis, 177, 14%, and non-specific shoulder complaints, 96, 7%. Temporary incapacity for work was reported in 83% of the reports and permanent incapacity in 6%. In 2/3 of the reports, the age of the workers was above 40 years. Slightly more female employees had an occupational disease compared to male employees, 50.4% versus 49.6% respectively. The economic sectors with the highest incidence of occupational diseases per 100.000 workers were the industry, 299, 95% confidence interval, CI, 256 to 343, transport, 248, 95% C, 192 to 303, and government, 247, 95% C, 203 to 291. Workers in lower socioeconomic positions, SEP, showed a 3 times higher risk of an occupational disease. Workers in lower September, for instance jobs in the industry, construction industry or transport, showed more temporary and permanent incapacity for work due to musculoskeletal disorders. Among the higher September, distress burnout comprised 60% of the OD diagnoses.